Hello friends, so in this video I'm going to explain you how to find the value of resistance of a resistor using resistor color code chart and find the capacitance of capacitor. So this is the aim of our experiment, and the instruments required are few resistors and capacitors. You can take 3-4 resistors and capacitors to study. Basically, you know what are resistors, right? Resistors offers a resistance to the flow of current, and it acts as a voltage dropper. If you put a resistance in a circuit, some voltage will be dropped across that resistance. So if your supply voltage is 9 volts for example, and you have kept resistance in your circuit, and if you measure the voltage at the output, then it will be less than 9 volt because voltage will be dropped across the resistors. And resistor is a passive device. So what are passive and active device? Passive devices are those devices which do not require external sources for their operation. No external source. So resistor do not require any external source. And passive devices stores energy or maintain energy in the form of voltage or current. So they store energy. Fine. So our resistor is a passive device. Resistor do not require any external source and it stores energy. Our capacitor is also a passive device. Active devices are those devices which require external source. And they do not store energy, but they produce energy in the form of voltage or current. And the examples of active devices are diode, your transistor. They are active devices. So the devices that we are going to study today, resistor and capacitor, they both are passive devices. Passive devices are those devices which do not require any external source and they store energy in the form of voltage or current. They only alternate or reduce voltage through them. They do not need any source. So resistors have color bands on it. There are many types of resistor, but the resistors that are commonly used, carbon composition resistor, they have color bands on it. So the value of the resistance is not written on them. You have to identify the value of the resistance by studying those color bands. So there are 3, 4 or 5 or even 6 color bands in carbon composition resistor. So somewhat like this, they look like this and they have color bands, as you can see, red, black, yellow. So in this video I will be telling you how to study these color bands. So let's make a chart. This is brown. This is black, not brown. Black, brown, red, orange, yellow, violet, grey, white, and gold, silver, no color. So how to remember this? Bill Brown realized only yesterday. Good boys value good work. And then gold, silver, no color. Bill Brown realized only yesterday that good boys value only good work. Okay, so this is our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9. That's it. We don't have any values for gold, silver, and gold and silver because they will never be in the. They will never be first or second band. We'll explain you. Wait. So these are the values. So our first and second band, if it's a 4-band resistor, our first and second band will be a numerical value. So if it is a black color, then you will write 0. If it's a brown color, then you will write 1. If it's a red color, then you will write 2. And a third band will be a multiplier. Multiplier in the sense 10 raised to power 0. Third band, if it's black, then it will be 10 raised to power 0. If it's brown, then 10 raised to power 1. If it's red, then 10 raised to power 2. If it's orange, then 10 raised to power 3. If it's yellow, then 10 raised to power 4. And if it's gold and silver, then 10 raised to power minus 1, 10 raised to power minus 2. And our fourth band will be tolerance. No resistor is perfect. So tolerance is usually given by the manufacturer. The resistance value, if it's 50 and the tolerance is 5%, then it will be between 45 to 55. So we have different tolerance value for all the color, but usually our last band, that is the fourth band, is gold and silver or no color. There is no color. There are only 3 bands. So for tolerance value of gold is plus minus 5%. Tolerance value of silver is plus minus 10%, and for no color is plus minus 20%. Fine. So, and if it's a 5-band resistor, then the first 3 values will be numerical, fourth will be a multiplier, and fifth will be tolerance. If it's a 6-band resistor, then the 6th will indicate the temperature coefficient. 6th band will indicate temperature coefficient. So in this, first band is red color, right? So red is 2. So we will write 2. Second band is black color. Black is 0. So we will write 0. Third band is yellow. Yellow is what? 4. Third is multiplier. So we will write 10 raised to power 4 ohm. And tolerance golden. Tolerance golden is plus minus 5%. See, plus minus 5%. Okay. So in this one, first band is brown. Brown is 1. The second band, even the third band is black. since it's a 5-band resistor, the first 3 bands will be numerical values. So 0, 0. Fourth band is orange. Orange is 3. So 10 raised to power 3 ohm. Then fifth band is brown. Tolerance of brown is 1. So plus minus 1%. So that's how you will calculate. You can also write it as 100 kilo ohm rather than writing 100 into 10 raised to power 3 ohm. This can be written as 200 kilo ohm. In this figure it is clearly shown. Blue is 6. Right? Blue is 6. Then white is 9. So 6. White is, oh, they think it's grey, but I think it's white. It's clearly white. It should be 9 according to me. It doesn't seem grey color. Grey is 8. So you see, okay, properly whether it's white or grey, whatever color is it, write the value accordingly. Then third is red. Red, you know, is, oh, this one also they said it's brown, but it looks like red color. So according to me it should be 69 into 10 raised to power 2 ohm plus minus 5%, because last band is golden. You can also write 6.9 kilo ohm plus minus 5%. Now capacitors. Capacitors are also passive devices. They are used to store charge. They are used to store energy. Basically, there are two plates. Both are oppositely charged, and an electric field is generated, and this arrangement is used to store energy. So capacitors, we have polar capacitors, polarized capacitors also, and unpolarized capacitors also. Unpolarized capacitors are called ceramic capacitors. Ceramic capacitors. And polarized capacitors are called electrolytic capacitors. So if two capacitors are given to you, how will you identify whether it's a electrolytic capacitor or ceramic capacitor? So the identification tip is, in ceramic capacitor, both the legs, if this is a capacitor, these are two legs, they will both be of same size. And in electrolytic capacitors, the two legs will be of different size, different length. One will be longer, the other will be shorter, and in ceramic both will be of same length. So in electrolytic capacitor, we have two legs of different length. So it's usually written which one is positive and which one is negative, but for you to remember, the longer one is always positive and the shorter one is negative. So I will show. So this is your ceramic capacitor. The value is written in the form of 103. So how to decode this, I will tell you in the next video. And this is our electrolytic capacitor. So this is positive and this is negative. So the value is written here, 47 picofarad. So there is no need to find the value for this, but for ceramic capacitor you need to find the value. So in the next video I will tell you how to find the value of a ceramic capacitor. It is a short video. I will tell you there. Thank you. If you like this video, then subscribe to my channel. Thanks for watching.